Hello and welcome to a video presentation on line graphs. Here's what you'll learn: how to display and analyze data in line graphs. First of all, what is a line graph? Well, a line graph is a graph that uses line segments to connect data points. Line graphs can be used to show how data changes over a period of time. Now let's analyze a line graph. Use the graph below to estimate the population of Arizona in the year 1990. Before we do that, let's make sure we understand the graph that's being shown to us. At the top of every graph you should find a title. In this case, the historical population of Arizona. On the left-hand side you should find a label for the vertical axis. It's the population in millions, and it goes from 0 all the way to 6 million at the top of the graph. Time will be along the horizontal or bottom axis in 20-year increments from 1920 to the year 2000. Now that we understand how to read the graph, let's estimate the population of Arizona in 1990. First, we have to locate 1990 on the horizontal axis, and we find it's right between 1980 and the year 2000. Draw a vertical line straight up until you intersect your line graph. Then draw a horizontal line over to the vertical axis and read the data off the graph. Since we're just looking for an estimate and our data point is very close to 4, we'll call the population of Arizona in 1990 about 4 million people. Now let's make our own line graph. The table below shows how the weight of a kitten increases with age. We want to make a line graph of the data. The first thing you should do is make sure you understand the data you have to graph in the table. The very first column shows the age of the kitten in months, while the second column shows the weight of the kitten in pounds. The first column of data are normally plotted along the horizontal or x-axis. The second column of data are normally plotted along the vertical or y-axis. First, let's go ahead and start labeling our graph by adding the ages along the bottom of the graph. They go in 2-month increments from 0 all the way to 12 months. Don't forget to add a title for that axis. It's the age of the kitten in months. Now let's figure out our scale for the vertical axis. We always start at 0, so let's add that at the bottom. Then we need to see how many horizontal lines are available for adding labels to the vertical axis. So let's go ahead and count them. There's 1, 2, 3, 4. So we want to evenly space the data out among those 4 lines. To do that, simply take the largest number you need to graph and divide it by 4. Looking in the second column, we see the largest number is 7.2. So we want to take 7.2 divided by 4, and you get 1.8. But intervals of 1.8 are awkward, so we're going to round that up to 2 to ensure our largest number stays on the graph. So start at 2, go by increments of 2, and work your way to the top of the graph. Now let's add a label for those numbers. It's the weight in pounds. With both our x and y axes labeled, we can now start plotting our data points. At 0 months, when the kitten is first born, it weighs 0.2 pounds. So locate 0.2 above 0 on the horizontal axis and plot that point. Work your way down the table, locate 1.7 above 2 months on the horizontal axis, and plot that point. Locate 3.8 above 4 months on the horizontal axis, and plot that point. Locate 5.1 above 6 months on the horizontal axis, and plot that point. Locate 6 above 8 months on the horizontal axis and plot that point. Now locate 6.7 above 10 months on the horizontal axis and plot that point. And finally, our last point in the table, locate 7.2 above 12 months on the horizontal axis and plot that point. Now the last thing we have to do is connect the points with a straight line. And don't forget to add a title for our line graph. We'll call this growth rate of a kitten. And voila, we're done. You've created a line graph, the growth rate of a kitten. Congratulations, you've learned how to display and analyze data in line graphs.